Good evening, and very happy that you stayed until the end. I will talk to you about the relationship between tree diversity and human health, and I will put that in a broader context of overall health of the social ecological system. I would like to thank already Loïc Gillereau, which was a PhD student of mine who did quite a lot of this work, and also some large communities where I worked in, the TreeDivNet community, with experiments that I will touch upon, and the Dr. Forest community. Dr. Forest was a EU Biodiversa project exactly on this relationship between tree diversity and human health. We're talking in a larger concept of what we call One Health. It's defined by the World Health Organization as an integrated, unifying approach to balance and optimize the health of people, animals, and the environment. So it's the idea that humans, for their health, they need ecosystems. And of course, if they rely on ecosystems, also these ecosystems need to be healthy, otherwise there cannot be human health. So human health and ecosystem health altogether is health of the overall social ecological system. And I will touch upon it in 3 steps. First, the effect of tree diversity and forests in general on human health. Then I will look on tree diversity in sea for the ecosystem health, and then I will bring the two together in step 3. But so first, the effect of trees and forests on human health. And when we look in the literature, there's a lot of recent literature on this. There's clear positive effects on the attention and mood of people, a negative effect on stress, so it decreases stress and anxiety in people. Also, positive effect on the physical system, the immune system, and so on. Less UV in forest, less extreme temperatures, and also forests seem to have a positive effect on social cohesion, control of aggression and violence. So that's what we learn from the literature. Only there's very little research so far on the effects of tree diversity. So we know that forests in general have an effect, but we don't know really the effect of tree diversity. Effect of forest and green as a whole, it can be really quantified, and here you see a study that showed that greening of the cities would save like 40,000 or more human lives per year in Europe. And yeah, the World Health Organization criterion is that every citizen in a city should have a green space of at least half a hectare on less than 300 meters from their homes. So yeah, you see where the red dots are, all the cities which lack green and which in fact are killing their citizens. Okay, so our Dr. Forest project. How does biodiversity, or more specifically tree diversity, affects human health? And we looked at several things. First, the effect on heat stress mitigation, and then also other health outcomes. So we'll start with the heat stress mitigation, what we call the thermal comfort. And okay, you could of course measure in the forest the climate or the microclimate, but what we did was to measure the physiologically equivalent temperature, and defined as the air temperature of a standardized room that would generate the same temperature perception as the observed outdoor environment. Just to give you an example, if you are in a forest, in the shade, it's 20 degrees Celsius, air temperature, there's no wind. That is the kind of perception you would have in a room, so with no air movement, no wind, it feels like 20 degrees. But yeah, if you're standing in the outdoors, it's 20 degrees Celsius, but the sun is shining on your head, you will have another perception. Because yeah, there's the radiation of the sun, maybe there's also a cooling wind or something, so that's this PET. And yeah, there's a model and this model needs input, and this input we measured here with these sensors. We measured the radiation, the wind speed, the humidity, and the air temperature. And all together that goes in a little model that gives us this physiological equivalent temperature. We put those instruments in a whole range of forests along a tree diversity gradient, both in young experiments in different places in Europe, but also in older mature forests. So for example, here in Białowieża forest, we also had this plots along a gradient of tree diversity in mature forest. And in all this forest, we had the sensors, and we could measure this physiological equivalent temperature during a whole year. And yeah, if we look at the daily means, we can see that in all these plots, the young plantations that you see to the left and the older mature forests, that yeah, forest is really buffering this human temperature. On the cold days, it's warming, it's having a buffering, a warming effect, and in the hot days, it's having a cooling effect. But more interesting is if we look at the maxima, so the maxima of the days, and there in the young plantations, we see a very strong cooling effect, even in these young plantations. But if we look in the mature forests, it's even more extreme. So this physiological temperature, what humans really feel, the cooling can be up to 14 degrees Celsius. It's really tremendous. So this is very strong effect of forests on human beings that can save lives. Yes, yeah, we put this data in a structural equation model to understand better what factors in the forest are now really driving this strong cooling. And we looked at factors that have to do with forest diversity, so Shannon index of tree species, the forest structure, and the species composition. What did we learn? That is that diversity is not having any significant effect. Of course, that also means it does not have a negative effect. Later on in my story, we will see that tree diversity has very important positive effects on other things. And if it doesn't harm the cooling effect on human beings, that's good news. But it's mainly forest structure which is playing this cooling role. And it's quite well known that the forest cover, so the basal area of trees, has a very strong effect. It's not only shading effect, you also have the evapotranspirative cooling. But what was quite a surprise that is that also the tree height plays a role. Higher trees matter. And then species composition. Species that have a stronger shade producing capacity, like beeches, in contrast to birches, for example. So late successional tree species, they have a stronger cooling effect. Then the leaf area of single leaves. Smaller leaves have more cooling effect than bigger leaves. I can't go into detail, but it has to do with the fractal dimension. If you have a spread of very small leaves, there's less clumping in the canopy, and your filter becomes more effective. And then also the share of deciduous trees has a negative effect of the cooling. So more conifers has a more year-round cooling compared to deciduous. And of course, the control, it means the climate outside the forest plays also a role, and we have seen it in the previous slide. In more extreme, maybe I need to go, in the more extreme days, the cooling is stronger. So that's really interesting. The hotter it becomes, the more the forest is cooling. So if we have a small intermediate synthesis on that, forest characteristics matter, mainly structure, so the canopy cover, the stand density, but also the canopy height. So trees have to be big to have the full experience. Then the tree species identity, so the shade casting ability, and also the fact of being an evergreen. And then, as said, the diversity has no significant effect. Okay, so that's the effect of this cooling. I would like to show this other study made by colleagues in my division, and they looked at the healing power of large trees. They had access to data from consumption of medicines in areas of the city of Brussels. And they could relate the consumption of medicine to control mental health and to control respiratory and cardiovascular problems. And they related that to tree cover. And as you can see here, so both for male and female persons, there's a very strong effect, a negative effect of tree density and a positive effect of tree crown volume. What does that mean? In areas of the city where there's more crown cover, but it's not only cover, again, it has to do with tree height. It's a crown volume. The more crown volume there is, the more healthy people are. And it's important to know that this has been controlled for income. So we know that there's a kind of tendency that the greener areas, also the richer areas, we controlled for that. And even then, areas with more mature, big trees have a stronger effect on human health. And tree density, it means that if you have a lot of small trees, like in many areas where they plant trees and 5 years later they cut them already and they restart because of public works, that has no effect on human health. On the contrary, it has a negative effect. Okay, so that is effects on physical health. Let's go now to effect of forest diversity on mental health. Also a study and framework of Dr. Forrest. And here we did a multicentric study. It means in different cities, in Leipzig, in Vienna, and in Louvain-la-Neuve near Brussels in Belgium, where we tested healthy persons to see what would be the effect of tree diversity levels on their well-being. And here's the setup. We brought people to an urban setting. We measured their thermal comfort. We measured their stress levels. We brought them in a blinded van to an unknown destination. And some people ended up in a diverse forest with lots of tree species, others in a less diverse forest, and even others in an urban environment. And so we measured, after that we also took a survey. We interviewed them again on their well-being, on their thermal comfort. But we also measured physiological activities, in this case, saliva, cortisol concentrations. And of course, we knew we measured the thermal situation as well. And what did we find? Very interesting. There's a strong positive relationship between forest diversity and mental health, but not with the real or absolutely measured tree diversity, but between the perceived biodiversity and this mental health. So stress levels decreased with increased perceived biodiversity, and so this feeling of restorativeness increased. What is perceived biodiversity is the biodiversity that people perceive. So you ask people, is this a diverse forest, yes or no? If they say yes, they have lower stress levels and they have a more positive influence from the forest on their mental health. What does it mean, this perceived biodiversity? So it's not directly related to tree species diversity. It has more to do with structural diversity, functional diversity, or also it's dependent on their cultural backgrounds on what they conceive as perceived biodiversity. And also very interesting that is that there seems to be a positive feedback between this mental well-being and the thermal comfort. So the thermal sensation, many people felt too hot in the city and not in the forest. Even many people felt cold in the forest. But despite the fact that they felt cold, they also felt comfortable. So there's a positive association. If you come in the forest, you feel well. So your mental well-being is good, and it gives a positive idea about the thermal comfort, and the thermal comfort is again strengthening this mental well-being. Okay. So we have already the effect on the trees, heat stress mitigation, on the mental health. Let's have a look at some others. So health outcomes of diverse forests on, for example, medicinal plants, fungi, fine particles, and there can be, of course, also what we call negative ecosystem services, like tick occurrence or even occurrence of Lyme disease because of entering into the forest. So the effects of forests are not necessarily all positive, they can also be negative. I come to this. So here you see the effect caused by tree diversity. The first column by forest structure, the four next columns, and then by forest composition. And then you see the effect on different, let's say, ecosystem services that have to do with human health. And green means a positive effect, red means a negative effect, and the larger the circle, the larger effect. So you see that for several of these ecosystem services, there's a positive effect, but these positive effects of tree diversity are quite low. The main effects are based on tree structure. Quite a lot of them are positive, but there are also a few negative. So that means that there are trade-offs and that we can never optimize the management or the structure of a forest that would be good for all the human health positive effects. There's always choices to make and solutions to find for these trade-offs. So these results are results of a trained Bayesian belief network where we modeled, let's say, the probability of a positive health outcome of these different aspects of tree diversity, tree structure, and tree composition. All right. Yeah, here you see this trade-off analysis. Lines are significant effects, dotted lines are not significant, and so the red lines are trade-offs and the green lines are win-wins. So let's come to some conclusions on this human health, and then we continue with ecosystem health. So forests generate net benefits. It's mainly canopy density which is playing a positive role, and there are trade-offs to take into account. And tree diversity is sometimes positive, not always, but it's never harmful. Okay, then we come to biodiversity and forest ecosystem health, because remember, we are not only interested in the health of human being, but also the health of the ecosystem, because if we don't have a healthy ecosystem, we cannot help the human. How do we study that? There's a whole bunch of research, and TreeDivNet has been very important to study that in forests. It is a network of experiments worldwide where we manipulate the level of tree diversity, and then we are able to measure all kinds of responses in terms of ecosystem productivity or resilience or associated biodiversity or you name it. Just to give the example of island Ethiopia, where I'm a PI, so we have a tree species pool of 9 native dryland species, and we planted plots of monocultures, 2 species and 4 species. So they have low or high species diversity levels, but they also have low or high trait diversity levels. And so you can have a 4 diversity species plot, but it can have a low or a high functional diversity. And then we have a second factor, which is the shading, because we consider that in dryland forest restoration in Ethiopia, shading much better than irrigating can be an interesting way to be successful in restoration. So that was just an example to give you an idea how we built this information on tree diversity effects. And there's, let's say, families of effects. There's effects on productivity, effects on stability or insurance, and then effects on multifunctionality. In the left-hand side, you see this synthesis paper of Cardinale, and in most studies, we find a quite strong positive effect of tree diversity on productivity. But it has an asymptotic behavior, so yeah, you can add 2 or 3 species and then the productivity goes up, but yeah, it levels to a certain asymptote. But you see also that the uncertainty range is decreasing. So the more diversity you have in your system, the more certain becomes the outcome. And in times of uncertainty of climate change, this is of course a very interesting aspect that tree diversity is stabilizing the productivity of forests. And then to the right, you see this conceptual figure of multifunctionality. The idea is that if you mix species, they all have some strong points and some weak points. And by bringing them together, you get what we call a jack of all trades and a master of none. So mixed systems, they are not specialized in something, but they are able to do a lot of things in a rather acceptable way. So they become multifunctional. Just to show you some ideas from, or some results from the studies we have done, not only in experiments, but also in observational studies in mature forests. And this is again the example of Białowieża forest, where for the Fundiv Europe plots, we looked at it with satellite remote sensing, used NDVI, temporal series, to measure the brutal ecosystem production over a season, over a year. And you see that over all these years, there's a very systematic stabilizing effect on forest productivity by diversity. So monoculture plots here in the Białowieża forest, and it's not a strict reserve, but the state forest. In the monoculture plots, there is a much higher spatial variability. So the outcome is less certain. So this is the evidence for the stabilizing effect and then the multifunctionality. This is a study over whole Europe, but Białowieża forest is again into that. So you have a number of tree species, they all have traits and functions. And if you measure in more diverse forests, you will measure higher levels of multifunctionality. Okay, we come now to the third and last part of my story. We know that healthy forests help the health of human beings in a very positive way. And we also know that tree diversity can help to make the forest stable, productive, multifunctional. But how can we translate that now in management at the landscape level? And there's a lot of scientists pleading for land sparing approaches. Land sparing means one part of the ecosystem we put and set aside for conservation, and other parts we will use for plantation forest, very intensive production, because we also need wood and other materials to get rid of the fossil fuels and to go to a circular bioeconomy. But yeah, if we do this separation, this may be good for biodiversity, but because from the moment that you start to intensify a system, the most sensitive species will disappear. So this is not a linear relationship. That's why land sparing is a very good option for conservation. But for human health, it's maybe not, because we want to have the green areas all around where human beings live. So land sharing has been proposed for all these multifunctional interests of forests. And so this is what happens in many ecosystems in Europe, that we go for a multifunctional forest approach, a land sharing approach. But yeah, both have advantages and disadvantages. So our understanding of today is that we need a triad approach. And a triad approach is a mixture of land sharing and land sparing options in a landscape. And that's what you see here in the middle. And so you see the red dotted line, which is just a triad example. It would be a landscape where 60% of the area is multiple use, 20% is intensively managed, maybe with exotics and maybe in monocultures, and 20% complete set aside for biodiversity. Okay, this is very theoretical. So if we translate that now to a landscape, where do we put what? Because of course there's interactions that can be positive or negative. And yeah, you can read a bit more in this Forest Biodiversity in Europe report. It's from Science to Policy report that has been published by the European Forest Institute. And yeah, this is the kind of landscape I think most of us have in mind, where you have in dark green the strict reserves. Then they are embedded in a multifunctional forest where we have close to nature forestry, and that is probably also dominated by native tree species, and where we keep the exotic tree species more separate in intensive plantations. All right, so are we okay with that? I think not, because there's one elephant in the room, and it's like a kind of taboo. We don't talk about it, and it's anthropogenic climate change. And what is happening here? Well, we know that the optima of tree species are shifting. I have that in my course since more than 25 years, that spruce will disappear from the Central European mountains. It's our main economic tree species. Nobody believed the scientists, so we are still with all that spruce after 30 years. But nobody thought that, yeah, this would come all at once with extreme events. We have the bark beetles, we have the fires, we have the storms. And in many parts of Europe, we see, for the moment, a complete collapse of forests. I don't know if you have it in your area, then you may be happy. But yeah, maybe you travel to the Hartwald in the Rhine area, big sandy soils in the Rhine Valley, Karlsruhe, Freiburg. Massive mortality of Pinus sylvestris, the native tree. Betula pendula is almost extinct from that area. So the native tree species do not survive. You have a collapse. And what comes in? The invasive exotics, Robinia pseudoacacia, Ailanthus altissima, and Quercus rubra, are the ones that form this forest. If they would not be there, there might be even shrubland or temporarily situation without forest. So what are the consequences of that? Of course, the productivity for our circular bioeconomy we dream about, we can forget about it. But also for biodiversity, this has effects. So biodiversity species which are strictly related to forest continuity, to what we call ancient forest, they might suffer or get extinct. And remember, forest height is important. We need big trees, continuous forests, forest microclimate, both for human health, but also for biodiversity. So there's a risk that we start to really lose in different parts of Europe very crucial forest ecosystem services and forest biodiversity. So resilience becomes our key factor to have forest continuity, because all the forest ecosystem services depend on this continuity. And here is the problem. We have a kind of paralysis, because you would think that everybody is working now to build this resilience in the forest. I can tell you almost nothing is happening. We are paralyzed because of several lock-ins. And the lock-ins are from the different sides. They are from the side of the business, and they are from the side of the conservationists. From the side of the business wants to do business as usual. So it are the forest industries which dictate to the foresters to keep the monocultures, to keep the spruce, because they say this is the only thing we like, or that our machines can saw, or that our clients want. They don't realize that in the future it will be the climate and the forest which will have to dictate the industry, and not the other way around. But also in conservation there's a problem. If I look to the EU habitat regulation and even the new restoration law, I claim that they are not climate proof, and certainly not their national implementation. I can tell you that 3 months before the approval of the European restoration law, tree diversity was not named or not mentioned as an indicator of restoration success. The tree net, we had to lobby ourselves to get it in. It's there now. But there's still quite a lot of bugs there. Just to give you a few examples. In our Belgian coastal system, we have a natural establishment of Quercus ilex, an evergreen Mediterranean tree species. I think it's welcome, because that's the future forest of our region. So we are fighting the natural adaptation to climate change. And we spend a few millions of European live money to get these dirty exotic trees out, while I think it's the future of our forest. So you see, we have to, I think, rethink the way we understand nativeness. And funny enough, we define nativeness and a list of native species based on our political boundaries. And I wonder what tree species have as a message to the fact that Flanders is a political unit within Belgium or Luxembourg or Andorra or something. I think it's not very useful. So we need to rethink nativeness based on indicators of co-evolution. Which species have had some level of co-evolution in the last millions of years? Which species have lower invasiveness risk? Which species have can make associations, communities with our associated biodiversity in our systems? And we lack a lot of scientific knowledge on that. And yeah, there has been a few studies saying, if you take a native prunus, it will have so many associated species on their leaves, and then an exotic tree, it has much less. It's very scarce, this research. And recent research shows that it's not so straightforward. So we need to work a bit on that. Anyway, what I'm pleading for are a few things in here now. We should harness the strength of mixture. So not fight the mixture, but welcome the mixture. And we speak about a functional complex network. So we foster natural regeneration, and we welcome all the species we have in our system, even if they are not in the list of the habitat. If you have a beech which is growing in your Quercus betuletum, please welcome it instead of, we have to eliminate it because it's not in our list of species for this habitat. I will show you with our university forest. If we do a normal forest inventory in this forest, it's a monoculture of pine with some admixture of oaks and birch. It's on the sandy region in Belgium. So in our normal forest plots, we take trees of more than 10 centimeter diameters. We only have plots of 1, 2, or 3 species. We started to look with other eyes. Now we do a full inventory. Not only in the plots, we go everywhere. We measure all the woody species that can grow more than 2 meters high. So we measure them in all stages of development. Seedlings, saplings, mature trees, and so on. So this monoculture forest that we had in mind based on our forest inventory now becomes a forest with 45 species and some stands which have more than 20 species in just one stand. It gives a completely different perspective on the climate change resilience of our system. And of course, it also allows us to see the gaps. We look at functional diversity, we look at functional redundancy, we look at functional connectivity, and we identify the gaps in our forests. Maybe there are areas which have really a lack of functions, where just losing one species would be a catastrophe for pioneering or late successional species. And there we can fill them in by planting, enrichment planting, of native trees, or maybe what we call native European species. And then we come to what we call assisted migration. So we accelerate the migration of the species. And does it make sense? I think yes, because the speed of climate change is more than 10 times higher than the natural speed of migration of the tree species. So this changes go much faster than what happened after the glaciations. And if we don't help the nature, we might come to collapses where not directly other species are ready. Nevertheless, is this a pleading for planting Southern European species everywhere? No, there's also a strong need here, the last column, conserve genetic diversity, to conserve biodiversity. And so it's the idea that in the landscape we have areas where we really work with what we have in our native potential. And how do we do that then? So I come back to my drawing of before. So maybe we can have a difference between what is ecological valuable, Natura 2000, and then other multifunctional areas with sustainable forest management. In the Natura 2000 areas, we have still our strict reserves. We have our genetic reserves, where we have the autochthonous material, which is very important because it has a higher genetic variation. It's maybe also material that will be needed to help our neighbors in the north, to provide them with new material for their assisted migration. And we keep the natural processes, but we stimulate natural regeneration and mixture. And then in the other areas, I plead for active exploration of the possibilities of assisted migration, to not lose time, to win time. And of course, yeah, there can be exotic plantations, but we have a whole, let's say, initiative with the FAO, with the World Food Organization, to plead even in the exotic plantations, so really in the intensive commercial forests of this world, to go for mixture and to really build resilience and believe that this is the insurance of the future. So we don't believe in monoculture plantations anymore after what we see with collapse in recent years. Okay, so let's come to conclusions. Climate smart management of our forest resources, which is also good for human health. We can implement the 330-300 rule of Cecile Konijnendijk. I don't know if you're familiar with it. It says that every citizen should have, if you open the window, at least 3 trees in the view from your house. A green cover of at least 30% in the neighborhood, and on less than 300 meters, some nice green area where you can go playing with your children or sitting on a bench as elder people in urban environments. But I want to add a fourth rule to this 330-300, and it's the active promotion of big and high trees. our research has shown that a tree is not enough. It needs to be a big tree, because big trees have big crowns and they have much stronger effect on this human health. Then take really into account what is happening with climate change and consider the options of assisted migration in plantations and multifunctional forests outside Natura 2000, while we should focus on self-adaptive processes in Natura 2000 and much more harnessing the strength of diversity, of functional and species diversity, and not concentrate too much on this restricted habitat and nativeness idea. And so also in plantations, we plead for mixtures in support of the circular bioeconomy. That's all. I thank you for your attention.